So today we're reviewing for the test. We did our anchor time right before this. And here's your first little taste of, you got to remember how to factor. You guys are a little late, but I'm happy you're here. You got to remember how to factor. So everybody please factor this. And then try to figure out what the vertical asymptote is. Hint, they make the bottom zero. Unless it's a hole. Figure out what the hole is, because it can't be a hole and a vertical asymptote. It's one or the other. And last but not least, the horizontal asymptote, because that's the idea of putting in 1,000 and seeing what happens. If you put in 1,000 and you just get 1,000, it's not limiting out. There's no asymptote. If you put in 1,000 and it gets closer and closer to 1, well, then your asymptote's 1. All right, I'm going to give you a minute. Try to figure out the vertical, horizontal, and the hole for this rational function. Okay, so first off, you had to factor it. And then I recommend you cancel what you can cancel. In this case, that's this. And then rewrite it. A lot of people don't do this, but then a lot of people get the hole wrong. This will really help prevent that. It also helps with the horizontal asymptote. All right. So now I've got it rewritten with what I had left. The vertical asymptote is what makes the bottom 0. So what makes the bottom 0 is x equals 0. The horizontal asymptote is when you put in 1,000, does it get closer and closer to anything? Would you agree that's pretty much 1,000 divided by 1,000, and therefore that's about 1? Now if you're ever like not sure, because there's going to be weird ones, if you're ever not sure, then put in a bigger number and see if it's still close to 1. All right, so like in this case, if I put in 1,000,000 over 1,000,000, it's still pretty much 1, isn't it? So if it stays where it was, then that's probably the limit, and therefore y equals 1. If you put in 1,000,000 and all of a sudden you get a bigger number, well, then it's not stopping. It doesn't have a limit. If you put in 1,000,000,000 and it gets even bigger, well then it's not stopping. It's going up, and it doesn't have an asymptote. All right, the hole comes from this. And I think you all know that 2 is part of the hole, but do you know the rest? 2 comma what? Well, this thing helps me figure out what the hole is. This simplified equation at the end, x plus 2 over x. And the hole, when I put in 2, gives me 4 over 2, which is 2. 2 comma 2, raise your hand if you got that one right. Cool. And last but not least, we haven't talked about this in a long time, the domain. Domain is what you can safely feed that function. X values, that would work. If all you say is what doesn't work, that's not useful. You got to say all real numbers like this, and then include what doesn't work. All real numbers except x cannot be. And some people are like not sure whether to include the hole or not. So I want you to think it through. Do you think it's both x cannot be 0 and x cannot be 2? Or do you think it's just the x cannot be 0? I'm really asking. So think it through. Think about whether or not, from the definition of domain, which is what can you safely feed that function, and talk with the kid next to you. Do you think it should exclude both 0 and 2 or just 0? Give an opinion to the kid next to you. All right. Most people are agreeing that both are excluded, and you are right. If you're like, but it just 2, 2. No, that's not a point. It's the absence of a point. There's no point at 2 comma 2. When you put in 2, you don't get anything. And if you're really not sure, stick the 2 in. And you'll end up with a 0 on the bottom, and you'll be like, oh, I guess it doesn't exist. All right. Then, let's say we had to graph this thing. I am honestly not sure exactly what this is going to look like. But I know what its horizontal and vertical asymptotes are, so that should help. And I know a point that's not on it, like the asymptote. So make an XY chart and find a few points and then actually graph them. So Brody, what's one point that you can put in, but it makes something weird happen?
0.
Yep. When you put in 0, you can see it. It's like, well, you're dividing by 0. That doesn't exist. That's an asymptote. When you put in 2, that's an asymptote. No, it's not. It's not an asymptote. What's the 2? That's a whole. Sorry about that. So then you should put in numbers on either side of those. Like you should put in -1 and 1. And we already are putting in 1, which is just on the other side of the whole. So then let's put in 3. Those 3 points will be key. And then put the asymptotes on your graph and then finish it off. This is the hardest question on the test. I'll pause for a second. And obviously it's not this exact question. It'll be something like this. Okay, let's see if you were doing those right. When you put in -1, just so you know how you're doing here. When you put in -1 here, you should have got 1 on top over -1, which is -1. So -1, -1 is a point on this graph. And when you put in +1, you'd get 3 over 1, which is 3. And those are working out really nice, which is why it's a really smart idea to test just on either side of the asymptote. Now, just on the other side of the whole may not work out quite as beautifully, but on either side of the asymptote works really nice. So I put a 3 in. 3 plus 2 is 5 over 3, 5/3. And that's nothing wrong with that. Yes, it's a decimal, but it's about 2, a little less than 2. You guys get 5/3 for that? Okay. All right. So when you put in 3, you get 3 over 2 over 3. 3 plus 2, sorry. So 5 over 3. Okay. And now if I graph it, 0 is the asymptote. That's a vertical, as in vertical asymptote. The horizontal asymptote, when I look back at my notes here, the horizontal asymptote was at 1. So I'm putting a dotted line here. And then I'm going to put a point at -1, -1. That's like there-ish. And 1 comma 3, that's like there-ish. And 3 comma 5/3 is like there-ish. And now I've got a few points. I hope you know how to like connect dots. And these get closer and closer to the asymptotes, but never touch them. And this gets closer and closer, never touches. And it would have to go out that way. And now, classic mistake. I just graphed it, seems perfect. I got 2 swoops, I got asymptotes this way and that way, and I forgot the what? The hole. So at 2, I'm supposed to have a hole. So I go over here, and I go, well, if this is where 3 was, then 2 must be like there-ish. So I go over 2, and there's an empty spot right there. You need to make it obvious that that's a point that's different than the others. It's not a point. It's an empty spot. Make it really obvious. Empty on the inside there. Okay. So that is about as hard as this test gets. But every now and then, the easy ones are what get you. So let's do a little practice on some of the easier ones. That might actually be hard for some people. Just because it's like, what am I even supposed to do? Well, you're supposed to add them. But you can't add them until you got a common denominator, and so do that and see what you get. If this, because it was before break, has been too long, I'll remind you, multiply by the other denominator. Two plus x, or x plus 2, over 2x. Raise your hand if you had that one right. Okay. If you didn't get it before, do you get it now? Are we good? Just common denominators. It's not a big deal. All right, here's another one. Okay, now just don't forget, all you've got to do is change this to a times problem and then flip it, and don't forget to factor and cancel stuff. I'm going to pause for a second and give this one a try. Okay, I am flipping this over and multiplying it. So this was on the top before, now it's on the bottom. And this part that was on the bottom is now going to be on the top, but I'm going to factor it. And then I hope you noticed a whole bunch of stuff canceled. The x plus 7 canceled the x plus 7. This x can cancel this x. The x plus 2 can cancel the x plus 2. And the only thing we have left is x minus 2. I never said f of x equals. There's no like y equals at the beginning of this thing. If it was there, I'd want to copy it down at the end, but this is it. Who had x minus 2 at the end? Cool. So that one's not that hard. All right. So I would say the hardest thing, in my opinion, of this whole test would be one of these two things. Either if I give you an equation, like here's a parabola that's been shifted over down, it's over 3, and it's down -5. Can you write me an equation of that? First of all, you should be able to just write me an equation for that. It's got an x squared in it, right? It's a parabola. But at the end, you got to add this extra leap. What if there's a hole in it? Don't worry about that till later. But what if there's a hole in it right over 4? That's what I think is the hardest thing. And I don't think it's that hard. But I'll show you. The other thing that could be hard is those ones where you put in 1,000, those can be tricky. So we'll do a few of those at the end. So I'm going to pause here, see if you can get this equation right for a parabola that's been shifted right 3 and down 5. I'm pausing. I said there was 2 major things that I thought would be hard for you. The other thing is all these weird scenarios for the horizontal. Verticals are so easy. Whatever's on the bottom, you know, if I say there's an x plus 3 here, well, then the vertical is at -3. Super simple. But what if there's an x squared minus 7 on top? Well, it's still a vertical is -3. The verticals aren't hard. It's the horizontals that are. Would you please try to figure out the horizontals for that? Horizontal asymptote. It's that 1,000 idea. And then try to figure out the horizontal for this. It's an x squared at the top on the top problem. They'll all be x squareds. And the last one, anything that you can't tell what the power is, it's a squared. These all have different asymptotes. The horizontal asymptotes on these 3 are all different. They all have the 1,000 idea, and if you're stumped, try putting in something bigger, like 1,000,000. And if the answer keeps on being the same, well, then that's probably the answer. Okay, let's see if you and I think about this the same way. The number one thing you need to be able to do is simplify it a little bit, like, oh, -7 doesn't really do anything after you got 1,000, okay? And cancel stuff. Let's see if you did it right. So I'm gonna put in 1,000 here, and then the -7 doesn't really do anything. And then 1,000 here, +3 doesn't really do anything. It's, it does, on average, it doesn't really matter. But I'm now left with 1,000 times 1,000 over 1,000. I'm gonna write that out just to make it really clear. 1,000 times 1,000 over 1,000. That's what squared means. Then these can cancel, and I'm left with 1,000. So I put in 1,000, and now I've got 1,000. And if I'm not sure what that means, try putting in 1,000,000, and you'll get 1,000,000. And it means that it just keeps going up, and that means there's no asymptote. That's different than 0. All right, on to this next one. +2 isn't going to matter when you put in 1,000. Now, if you had $1,000 and I said I'll triple it, do you think tripling 1,000 matters? Yes, it does. Tripling 1,000 matters. Adding 3 to 1,000 doesn't really matter. Okay, so those thousands matter. And in fact, 1,000 times 1,000 is 1,000,000. So right here, that's 1,000,000, but so is that 1,000,000. So they cancel, and it's 3/4. Now, I know some of you were like, that's pretty much 1 and rounded to 1. Don't do that. Those thousands can cancel. And if you don't understand what I mean by that, try putting in 1,000,000. And you'll have 1,000,000 squared, which is 1,000,000,000. Oh, that's 1,000,000,000,000 actually, I think. Over 1,000,000,000,000, and it cancels again, and you keep getting 3/4. You cancel them. You can't round them at the end. So it's 3/4. Did anybody have 3/4 on that one? At least more than half of them. And I get some of you are like, oh, it's pretty much 1. Well, you can't do it like that. When you can cancel the thousands, cancel them. And then last but not least is this one, 1,000 and 1,000 squared. Well, the -3 isn't going to do anything. The -4 isn't going to do anything, but squaring definitely does. So then I'm left with 1,000 over 1,000 times 1,000, and some of that can cancel, remember? And is that just the same as 1,000? No, it's 1 over 1,000. And what's that pretty much? 0. Very good. Who had 0 at the end? Okay, cool. I know those are tricky, and you have time to ask me if you want one-on-one help on that. I can re-explain it to you. And now we have covered everything that is on that test tomorrow. All right, so this is the part where you've got a practice test. Strong recommend that you do it. Check it against the answer key. It's going to go in your homework grade. So it would really double hurt you if you don't do it. You're not prepared for the test, and you got a little lower formative score. On the other hand, if you do it, you can have a little higher formative score, and you're ready for the test. So that's my strong recommend for tonight. Do and check the worksheet. That's all I got for you for today.